So let's do another example here. Let's say that we've got a power supply. Let's make it a very big power supply, 1200 volts, and this is connected to basically two long rails, and able to slide along the rails is resistors. This is able to slide with very little or no friction there. Okay, and let's say the resistance is going to be equal to 0.65 ohms. Okay, we have a magnetic field, and let's say the magnetic field is into the screen, and let's say the magnitude of the magnetic field is half a Tesla. Okay, and let's say that these rails are separated by a distance of 27 centimeters. So what's going to happen? Well, current is going to flow like that. So current is flowing downwards in there. So that means it has a force because you have current flowing perpendicular to magnetic field. Okay, use the right-hand rule. That means the force is to the right. Now, how big is the force to the right? The force is going to be ILB. Well, we got B. L is going to be the 27 centimeters. And so all we need to find is I. Well, I is going to be V over R. So that'll be 1200 volts divided by 0.65 ohms. Okay, so that's going to be a whopping 1850 amps. Okay, so the force is going to be 1850 amps times 0.27 meters times a magnetic field of 0.5 Tesla, and so that's going to come out to be a very large number. 250 newtons. Okay, now that means there's a very large force pushing this thing down the rail. Now, here's the interesting thing. That force is going to be pretty much constant as it goes down the rail. And so it's going to maintain that force. Now, why is this of some interest? Well, this idea is the basics behind what we call a rail gun. And so the idea would be that you would have a large magnetic field. You would have something here that's free to move. A current would be flowing through it and the force. Now, in a normal gun, the way a normal gun works is you got the barrel, you got the chamber here, you got the bullet here, okay, so the cartridge, you got the bullet, and explosion here pushes it down. Now, what happens is the explosion is pushing it down, but as it goes down the barrel, the pressure drops. And so the force drops as you're going down the barrel, okay. As long as you're going in the barrel, you've got acceleration, but the force is dropping the whole way. And it's also pushing outwards on the barrel itself. So some early guns had a bad tendency of simply exploding. The breech would explode. And so that's bad. World War II, you have these great big artillery pieces like battleship guns, and they have to be very, very thick because you have the cartridge here, you got this round here, and so this has to be very, very thick. In fact, what they often did was they realized that you had a bad tendency of the artillery exploding, so they were actually wrapped with steel cables in there. Okay, but it limited how big your guns could be without actually blowing up the gun when you tried to shoot it. And so the idea would be if you could have these long rails, and then you have something that can move along the rails, and it just pushes the projectile along, then you could push it, and as long as you can maintain a large magnetic field and electrical current, you could push it with constant force all the way down the rails as long as the rails are. So Germany was actually working with this during World War II, and they were wanting to build like these rail guns that were like a mile or so long and hurl projectiles all the way to England with them. There was talk here of of doing this sort of thing on the moon, in which you can mine the moon, and it's really difficult to, for example, in World War II, they had difficulty maintaining that big of a magnetic field. But on the moon, what you could do is you could actually mine the moon and then put the ore in a projectile here, and then use capacitors, solar power, charge up all these capacitors, discharge the capacitors suddenly to make enormous magnetic fields with electromagnets, and discharge more capacitors through here to make an enormous current, and project the thing with enough velocity, possibly launch it off the surface of the moon. That way you could do this without using any rocket fuel. All you would need is solar power to launch this. And so the moon has that in abundance. So that's actually been a suggested way of mining the moon and sending things back to Earth. The Navy has experimented with railguns. The idea would be on a ship to have a railgun, and you could potentially launch something at hypersonic velocities. Velocities so fast that you don't even need an explosive round. Just a solid projectile would hit with enough force to destroy anything that it hit. Okay. Now, the problem is getting that much electric current to make an enormous magnetic field and to make an enormous current. Most of the ships that have guns are going to be destroyers and a few cruisers. Okay, well, we don't have a lot in the way of nuclear-powered cruisers. We don't have any nuclear-powered destroyers, and so that means it's going to be difficult to produce that much electricity. Well, there's another application the Navy is using, and that is the catapult used on the latest generation of aircraft carrier. The latest generation of aircraft carrier, the Ford class, what they're going to do, the plan is that they would have nuclear-powered aircraft carriers, so you have all these nuclear reactors to make a lot of electricity. And so what they would do is, instead of a projectile, they would use this to replace the catapult that launches aircraft off of the carrier deck. It's going to replace the old steam catapult. The idea being that this strategy would be more reliable and less likely to have a misfire. If you don't get a big enough charge of steam, you just toss your fighter jet out in front of the carrier and it hits the water. Okay, so you don't want that. And so this would be more reliable is the idea. Now, in tests, it's not quite as reliable as they had hoped, but this is the very first time they're implementing this. And so the hope is that it's going to be able to work in the end. But the railgun is a very interesting and fascinating concept that uses this idea of the electromagnetic force, the magnetic force acting on a current. All you need is a current and a magnetic field.